Okay, sorry about that. It took me an extra it took me an extra second to set up. Why is my mic not working? Okay, there it goes. All right. So it took me an extra second to set up. Everything looks good now. You should be ready to go. Um, okay, I'll talk about the test at the end. All right, so let me get started. Um, what you're seeing now is a concept that's not new. We did this activity in the very beginning of the year where we talk about transformations, and you're going to see lessons like this at least five more times, because what happens is for each set of new functions we learn about, we're going to be able to transform all of those functions. So in the very beginning of the year, we did linear functions and I shifted those around the coordinate plane. And today I'm doing quadratic functions. I'm going to shift those around the coordinate plane. And then later on, we're going to learn about exponential functions. I'll shift those around the coordinate plane. Logarithmic functions, I'll take care of those. Polynomial functions. There's a bunch of different functions we're going to learn about in here. And for each time we learn a new function, we're going to learn how to move that item around. All right. So this will be the second one. The first time we did this, we did it with lines and we moved those around the coordinate plane. But today we're going to be focusing on quadratics, and we're going to shift those around the coordinate plane. And the good news is this activity really takes advantage of technology. So Desmos will be an integral part of doing this. So we can use the technology to get a visual of what's happening. And that makes it a little easier. We don't have to just memorize a bunch of formulas. We can actually see what's happening. I prefer that to just memorizing. So if you forget, it's okay. You can always use Desmos and explore what happens. So we're going to get to do both of those things. For today, we're looking at how do the constants a, h, and k affect the graph of a quadratic function. Well, we're not going to get to take care of a today. That'll be tomorrow. So today we're going to look at h and k and how they affect the quadratic. And what I'm going to do is I'm just going to be describing transformations of quadratic functions today. All right, I'm not going to be writing these. That'll be tomorrow. So today is just going to be describing the transformations. So let me just read this little passage. We'll talk a little bit about quadratic functions, and then we'll look at how to actually translate those quadratic functions in the coordinate plane. So describing transformations of quadratic functions. Um, a quadratic function is a function that can be written in this form: f of x equals a, x minus h squared plus k. So that's the standard form. Okay, it's this. Where a is not zero. Well, honestly, if a were zero, you wouldn't have a quadratic, because if you take zero and multiply it by these other items, you're going to get zero. Multiplying by zero wipes out everything. So that's why it says this. The U-shaped graph of a quadratic function is called a parabola. So we did see this before. We know that these are quadratic functions. Okay, that's that parabola, and that's the equation. The most general one is x squared. Okay, and we've seen this again. There was one question on your exam, I think, was flipped over, and we know what it is. In section 1.2, which is like the beginning of the year, you graph quadratic functions using tables of values. You could also graph quadratic functions by applying transformations to the graph of the parent function x squared. So that's my parent, and by doing transformations, I can move the parabola around the coordinate plane. For example, I can move it up, I can move it left, I can move it right, I can move it down, I can move it like to the right and up at the same time, or down and to the right at the same time. So I can do a number of things. I can also make the graph vertically stretched or vertically shrunk, which we've seen previously. We're not going to get to do stretches and shrinks today, though. That'll be tomorrow. So today we're only going to be focusing on moving this item, x squared, around the coordinate plane. That's all we're going to look at today. Just moving it around the coordinate plane vertically and horizontally. Okay. So it's not a very complicated lesson today. We're only really honing in on two different skills. So let me let me show you what I mean by this, all right? And then we'll look at some examples. Okay, so I've presented little slides like these before where we've seen vertical and horizontal translations. I'm actually going to start with vertical translations, and then we'll pause, and then we'll take some questions about this if anybody has any. So let's start with vertical. Um, First of all, we're given the equation. I'm going to write the equation in red on top, it's big. So the equation is f of x. This is from the EQ. They said it's a parentheses x minus h squared plus k. Okay, so that's the EQ is using this. All right. Um, so we're going to start with vertical translations, and it turns out vertical translations are determined by k, the value on the outside. So this value determines the vertical translations. Okay, I'm just going to say vertical change. Okay, so this is vertical change. Um, okay, let's explore what happens as we change the value of k. So we're starting out with x squared, which is the parent function. It's in black ink. Okay, so there's vertical change in black ink. I mean, sorry, there's the parent function in black ink. Now, if you add to the function, if you add on to x squared, you'll notice that it's pushing the graph up. So for example, if I had x squared plus 3, okay, by adding 3, by making k positive 3, this would move the graph up 3 units, okay? It would move the graph up 3 units. Um, if you made the k 5, it would push the graph up 5 units, all right? So by making k a positive value, it pushes it up by that amount of units. So in other words, x squared plus k, okay, if k is positive, we're going to go up k units, all right? Now that's when it's positive. Now the question becomes, what about if it's minus? What if we subtract, okay, from x squared? So what if we do x squared minus k? Okay, well, if we do something like that, if we subtract from x squared, it's going to push it down k units. All right. So basically, by making k a positive value, we move it up by that amount. By making k a negative value or subtracting, we push it down by that amount. So if I had x squared minus 5, it'd be pushing it down 5 units. Now, I want you to see this in practice so that it can make sense. What we're going to do so we can visualize this, I'm going to take us out a notebook and bring us over to Desmos, and then we're going to get an illustration of what's happening. I'm going to put some numbers in, and we'll watch the graph change, right, in real time so we get a sense of what's going on, okay? And then I'll stop and take questions because I really want to make sure that we're all okay with these concepts. So let me bring us into Desmos now, all right? I'm going to come back to this. Let me just bring us into Desmos. Let's go over to Desmos. Okay, let me just clear this out. So let me just make sure we can, okay, get loaded. Okay, can I just have somebody confirm that we can see what's going on and that we can see Desmos? Can we see
Yeah.
it? Thank you. Great. So I'm going to start out with x squared. This is going to be my parent function. So regular old x squared just goes through the origin. It's centered. Its vertex is 0, 0. That's the parent. It's not being shifted around at all. Okay, it's in standard position. So let's say we try to add 3. Take x squared and let's add 3. Well, if I add 3, it pushed the graph up 3 units, right? It was originally at 0, 0. Now it's at 0, 3. that's a translation up 3 units. If I make it x squared plus 2, it's pushed the graph up 2 units. If I do x squared plus, let's say, 5, okay, if I make it x squared plus 5, you can see that it shifted the graph up 5 units. So whenever I add on to x squared, it's going to push the graph up by that amount. I hope that's okay. Let me just show you the other way and then I'll take questions. So it seems as if you add a number, it shifts the graph up by that amount. What if you subtract the number? Okay, I did x squared minus 2. So now look where I am. I'm 2 units down. Okay, I'm 2 units below where I was. Subtracting 2 has pushed the graph down 2 units. If I do x squared minus 4, okay, if I do x squared minus 4, this pushed the graph down 4 units. The minus 4 has shifted it down, okay? And exactly the amount of whatever k is, okay? So if I do x squared minus 3, it should go down 3 units from the original. Let's make sure. X squared minus 3, and we can see now we're 3 units below where we were previously. Let me stop and take questions. Are there any questions on what happens when you add k or subtract k? Are there any questions at all about that? Okay, so if we're okay, I'm back. I'm gonna go back to notebook. Let's go back to notebook. Give it a chance to load. Okay, so that's vertical translations. Okay, and the value k on the outside is what's going to have control over your vertical translations, and that's illustrated here. You can see the plus k on the out. Okay, that's outside. It's not in parentheses. It's outside. That's the vertical translation. Now I want to talk about horizontal translations now. So now I'm over here. Okay. Now, horizontal translations, I always teach those second. I did this last time too. I always do the vertical first because the vertical makes sense. Everything is normal when you do vertical. If you add, it goes up. If you subtract, it goes down. Okay, everything is normal. But we learned earlier in the year, horizontal changes are backwards. So if you're going to do um, y equals x plus h squared. Okay, when you add, it actually moves left h units. It moves left. Everything's backwards when you do horizontal change. Moves left h units. So when I have an addition to x, I'm moving left that amount. If I subtract, from x, right? If I subtract from x, I'm going to move right h units. And that's always confusing to people. Like, why is it reversed like that? Okay. Vertical is normal, but horizontal is backwards. And before I explain why, let me just make sure we understand the difference between the horizontal and the vertical. The vertical change, for vertical change, you're adding or subtracting on the outside. You're adding to x squared or subtracting from x squared. When you're doing a horizontal translation, you're adding or subtracting directly from x inside of x squared. So it's not the same thing. Vertical translations, you add or subtract from the whole function. Horizontal translations, you add or subtract from x directly. It's a different thing. It's a different thing. Okay, so that's how we know the difference between vertical and horizontal. And unfortunately, the horizontal ones are always going to be reverse of what you would think. If you're adding, you're going to be going left that amount. If you're subtracting, you're going to be moving right by that amount. And we did see this before when we talked about horizontal translation of lines. It's the same procedure, same process, everything exactly the same. These rules will not change. They work even in the more advanced things we do later in the year. So once we know these properties, they're never going to change. It's the same thing repeated over and over. So that's good. It's consistent. Um, the question though is why is it backwards like this? Why is it always backwards? And the reason is that comes from the formula. Okay, it comes from the formula. The fact that there's a negative here. I'm going to show you this in practice when we do an example. But for now, I just want you to understand that the age value, this value here, this controls the horizontal change. And I'll show you why it's backwards. You're going to just give me a minute to do that. Okay, that's the horizontal change. And before I get into the equation and explaining why it's reversed like this, let's just make sure my claims are accurate. Okay, let's make sure my claims are accurate. I'm going to go into Desmos and we'll do a few little examples where we add and subtract from X and we'll see what happens. All right, so that's the good thing. If you don't remember these things, you can always go into the computer and then figure them out by playing around with the values for yourself. All right, so you don't have to just memorize stuff. You can use the computer to help yourself a great deal, actually. This unit, if you're using the calculator, it's like a million times easier, especially with Desmos. So, so it really technology really shines here for this activity. So let me illustrate these. I'm going to go back to Desmos and use some numbers, and we'll get to see this in practice. So let's do that. All right. So let me make x squared my usual parent function. So this time x squared's in red. There's my parent. And now I'm going to subtract or add directly to x. So let me add first. I'll do x plus 3 squared. And look at what happened. By adding 3 to x directly, right, I've pushed the graph 3 units to the left. Okay. So by adding 3, I move it 3 units left. Let's see what happens if I add 4 instead of 3. Let's change this to 4. If I add 4, now it's 4 units left of the parent function. Okay, it's moved it over 4 units. If I add, let's say, 7, if I add 7, now it's shifted over 7 units, okay, from where the parent was. So by adding whatever number I add, okay, that's going to move the graph left. And this is h units, okay? So in this case, h is this value here. So it shifted it over 7 units. So by adding to x, whatever I add directly to x is how far left the graph's going to move. Any questions on that? Okay, so that's adding. Now, what about if I want to subtract? What if I want to subtract a number from this? Let's do that and see what happens. Let's subtract 3. Okay. By subtracting 3, now it's moved the graph right 3 units from the original function. Okay, there's the parent. Now it's right 3 units. If I subtract 2, now it's right 2 units. Okay, it's moved it over 2 units. Um, if I subtract 7, x minus 7 squared, now it's moved it right 7 units. So interesting here. When you add, we can see when you add to x, it's moving it left by that amount. When you subtract from x, it's moving it right by whatever the amount is. Okay? So that's what's happening. Now we've seen this in practice. We get to visualize everything. And if you get confused, I strongly recommend you just graph each one so you can see visually what's happening and then help yourself out. Okay? So that's what's happening there. Any questions on anything from that? Anybody have any questions, or are we okay? Anything? Let me just check the
No,
chat.
we're
No.
okay.
All right. No. Okay. Great. So it seems like we're okay with this. It's not very difficult, especially since we've actually seen this before with lines. So the property is the same. And I said you're going to see this again like 4 or 5 more times with each new item we learn about. So it does get redundant, but it's just worth doing because I want you to have an understanding of how each graph looks. So you get a feel now for how quadratics look. Okay, they're just parabolas. They're U-shaped. You know that already, but just to reinforce all the different things, the different features of each function, it's worth it just for that. So let's take a look at example one. Describe the transformation of x squared represented by this, and then graph each. Well, okay, I'm actually going to just graph x squared. That's the parent function. I know how that looks. That's the one that goes through the origin. I'm going to do the best I can. It's hard for me to graph this with a mouse, so I'm sorry. It's the best I can do. Use Desmos. It'll obviously be way more accurate. And when you make your diagram, just do the best you can. It doesn't have to be perfect. Okay. So that's kind of the best I can do there. It's not perfect, but it's okay. It's close enough. So there's my parent. Okay. Now the formula that I wrote down that comes from the aim from the EQ of today's lesson, we know that the thing is f of x. This is in the focus, by the way, is a parentheses x minus h squared plus k. And I wrote it down over here as well. It's the same thing. We know that h is the horizontal change and k is vertical. So once again, we know h is the horizontal change and k is the vertical. Okay, this is coming from the EQ and this is the general formula. Okay. Um, Now, they want us to describe the transformation. So explain what happens to the parent function f of x when you do this. Okay, so what's going to happen? In other words, how's it going to move? Is it going to go up, down, right, left, or some combination? Maybe it goes left and down, or left and up, or
It goes
right
left.
and down, or right. Yes? Sorry, what was that?
It goes left.
It goes left. Okay, let me write this down. So I have a claim that it goes left. How about up or down? So my claim so far is that it's going to go left,
It goes down.
left and down. Okay. So the claim we have is that this graph is going to move left and down. Okay. We're going to deal with this claim because we're going to graph g of x and then compare it to the parent, and we're going to see what happens. Now, let's do that, and then we'll explore why. All right. So let's see if he's the claim is that it's going to go left and down. Okay. That's the claim. So let's see if this is correct. I'm going to put x plus 4 squared minus 1, and then we'll talk about why that's the case. Okay, we'll talk about the algebra part in a minute. Let's explore it first. So let's see here. The function, load up. So I'm going to let Desmo load up. Okay, Desmo should be loaded up. And I believe, so my parent's in red. Okay, there's my parent. That's regular old x squared. Nothing to see here, just the parent function. And now I want to graph, what was it, x plus 4 squared? X plus 4 squared, and then minus 1, I believe. And I'm going to check this to make sure I did it right. X plus 4 squared minus 1. That's correct. So I did it right. X plus 4 squared minus 1. Now, his claim was that it went down and left. And it looks like his claim is going to be correct. Okay. This graph has shifted 4 units left and 1 unit down. Okay, it shifted 4 units left and 1 unit down. I can see that because the vertex changed to this new coordinate. So 0 became -4, that's 4 units left, and this 0 became -1, that's 1 unit down. Or you can just count the boxes 4 left, 1 down. All right, so I'm going to graph this 4 units left, 1 unit down. I'm going to do the best I can with my graph. It's not so easy to get these to come out nice, but I'll do what I can. Okay, okay. So I have to go 4 units left and 1 unit down. 4 units left and one down. So here's my new vertex. And there's my new parabola. Okay, this coordinate is 4 comma negative 4, excuse me, negative 4 comma negative 1. Okay, so he was correct. Okay, this was the correct response. The graph did move left and it did move down. Okay, to be exact, it moved left 4 units. Okay, we went left 4 units, left 4 units, and we went down 1 unit. So the claim was accurate. Now the question is why? Why? That's the question. Well, I'm actually going to address the down 1 unit first. Okay. We talked about this a minute ago. The K value, okay, the K value determines the vertical change. So in this question, the K value is -1. Okay, K is -1. So since K is equal to -1, this is why we're moving down 1 unit. Okay, the K value determines that, and K is -1. All right, that's why. Now, the H determines left and right. Now, here's the confusing part that I think sometimes students get messed up on. H appears to be 4, but it's actually not. Really, what this equation says is this. It really says x minus, because you need to have a negative sign, x minus -4 squared minus 1. That's what g of x is really, okay? So if you're wondering, hey, well, Rafusik, I see a plus there. I see a plus here. The reason you see a plus is because no one ever writes two negative signs like this. X minus -4 is x plus 4. But if you want to use the equation, you need to have a negative there. So if you say x minus -4, it's the equivalent of x plus 4. In other words, this statement right here and this are the same thing. That's legal. I can do that. They're equivalent. So I'm allowed to say that. So really, h is actually not 4. Okay, to make the negative sign, h is actually -4. So h is -4. And that's why we're moving left 4 units. So what happens is because of the negative in the equation, you're always changing your sign to find the value of h. If this says +4, it's really -4. If it says -4, it's really +4. The negative here causes you to have to change your signs with h. With K, that's not an issue because with K, the formula has a plus sign in it, so it's good. You just copy what you see. You're good. It's the H that has a negative in it, and that's why you're always changing the sign. And that's why it's always reverse when you're doing horizontal change. That's the reasoning. That's the algebraic rationale. Any questions on how I'm doing this? Anything at all? Anything? Okay, so I can only assume we're okay. Let me do one more example together, all right? And then you're going to get to practice a couple of examples by yourself, okay? So let's look at the next one because I want to make sure we understand this. It's not that hard, but it's a little tricky in the beginning if you're not used to this. So let's look at one more and then you'll try two by yourself. So that's it for this one. We have three questions with translations right here for us to do. And I'm just going to write down the main formula. The main formula is f of x equals a parentheses x minus h squared plus k. Okay, that's the general form. And this is given to you in the EQ. And at this point, we need to know that k represents the vertical change. I'm just going to write vertical. We know what vertical change means. And then h we know is going to represent the horizontal. Okay. All right. So describe the transformation of f of x equals x squared represented by g and then graph each. So I'm not going to follow the directions verbatim. I want to just graph x squared first, just so I like seeing x squared, the parent function. So I'm just graphing the parent really quick just so we can get a visual on the parent. And no, it never changes. It's always the same thing. It's just the basic x squared function, which you've probably seen like a million times in other classes. Okay, so there is the parabola x squared. That's the parent. And now I want to graph this. Now I know this doesn't look exactly like this. What I did in my other class was I did this. Right? That's legal because adding zero not going to change anything. I'm allowed to add zero to anything I want to. It doesn't change the value. All right. So I'm just making this equation look like this equation. So basically, g of x is x minus 3 squared plus 0. Do you have to write the plus 0? No. I'm just doing it so it could look like the original one. Um, and now I want to see what happens to the parent function if I do this. Is it going to move up, down, left, right, or some combination? I'm going to graph it and get the answer, of course. Before I do that, I want to hear people's predictions based on what you see. How do you think this graph is going to move compared to the parent? What is x minus 3 squared plus 0, which is the same as x minus 3 squared? How is that going to look? Which direction is it going to translate the parent x squared? Anybody have anyone to make a prediction? I'm going to check it, so we'll know in a minute. Yes.
It should move right.
It should move right. So let's see. Okay, let me write down your claim. The claim is it's going to move right. So I heard right. What about, is it going to move up or down, or no?
No.
No,
No, no up or down. Quick question. Why not? Why is it not going to move up or down?
K is 0.
because
Yeah, K is 0. It looks like K is 0. So in the K position is 0. So we're not going to be moving up or down. So no up or down. So moving right. So the claim is it's going to move right. Let me check this out. Let's see if it moves right. I have to do x minus 3 squared. Let me do that. Let's deal with this claim. Okay, it's loading up. Okay, so Desmo should be visible to everybody now. And my claim is I want to check out x minus 3 squared. X minus 3 squared. And her claim is accurate. It has moved right 3 units. It went from 0, 0 to 3, 0. That's a translation to the right of 3 units. And the other claim was also correct. Since k was 0, the graph did not move up or down at all. Okay, it just moved right only. So it moved right 3 units. That's the only translation we have. Okay. So I'm just going to go ahead and graph this on my notepad. So, okay, so I'm graphing it. The vertex is 3 comma 0. Let me do that. So, okay, notebook's opening up. Okay, there it goes. So I'm going to do the best I can here. It goes through 3, 0. So it should look something like this. Okay, so here's the new graph going through 3 comma 0. All right, and it was correct. The graph is moving, it moved right 3 units. Okay, right 3 units.
Mr. MPD.
Yes,
Um, so so when you don't have that like extra number on the side, you always like assume that it's zero.
that's correct because no one's going to write down a plus 0. So that's the implied value, right?
Hmm.
So I could put that there. I just drew that there to make sure to make g of x look like the f of x. That's the only reason I did it. The 0 is implied. It's not gonna, if it's not moved up or down, there's going to be 0. So yeah, you're correct. Okay, you are correct. And here's the exact way of doing it. Really, you're supposed to find h and k. So we can see that k is actually 0. Since k is 0, there's no vertical movement. No vertical movement.
Okay.
And H is the hard part. H is actually positive 3. H is positive 3 because, um, remember, it's X minus. You have X minus. In the H position, in the H position is 3. So H is 3. Okay, H is 3. This minus is part of the equation. X minus, we're subtracting 3. So 3 is in the H position. And because H is 3, it's 3 units to the right. Most students don't, they just change the sign. They just say, okay, I know because it's a negative with the H, I have to change the sign. So if I see negative 3, that means positive 3. You just change the sign. That's what most students do, which is fine. So H is actually 3. And that's basically, let me just take those marks off. And that's basically it. Okay. That's it. We got this thing graphed. So I'm going to give you a couple of minutes, okay, to do the same thing in examples 2 and 3. I'll write down the parent function so you could see it. The parent function is this. The parent formula, excuse me, is this, is x minus h squared plus k. That's the parent thing. And we know that h is the horizontal, and then k is the vertical, okay? So what I want you to do, for questions 2 and 3, you're gonna explain or describe the transformation much like I did. So an example would be the graph moves 5 units to the right and 3 units up, or the graph moves 7 units to the left and 2 units down. So you're just gonna describe the transformation for questions 2 and 3. um, my advice, try to figure out the transformation without using Desmos at first, like predict what's going to happen based on what you see. And then you can use Desmos to know if you did it right or not. And if you're stuck, you can just go straight to Desmos and just see what happens and explain based on what you see. But I really would like you to try to figure out what's happening without Desmos at first to see if you understand the algebraic manipulation. If not, that's fine. You can just go to Desmos straight away, and that's going to work too. That'll always work. So let me give you a couple of minutes, like four or five, like 4 minutes. We'll do 4 minutes because I want to be able to go over these really quick at the end. So take 3 or 4 minutes to work out these 2 examples. As you do that, I'll listen in, and I'm going to graph the parent functions while we wait. While I wait for you guys to finish. So while you guys work on those, I'm just going to graph the parents. Nah, it didn't come out too good. Maybe I'll do a better job over here. All right, so just take your time and figure out those what those translations are like. Oh, a little less than a minute, and then we'll take a look at these. Okay, so let's take a look at example two. Before I go ahead and throw this thing into Desmos, anybody want to make a prediction? At this point, you guys actually worked it out, so you know for sure. What's going to happen in example two? How is this graph going to shift compared to the parent function x squared? Yes.
2 units down and 2 units right.
Okay, so 2 units down and 2 units right.
Yeah.
Okay, so I have 2 units down and 2 units right. Let's take a look if that's what's going to happen. X minus 2 squared minus 2. So let's take a look. Okay, let's open up Desmos. And here we go. It should be loading up. So it should be visible now. So it's x minus 2 squared. Let me do that. X minus 2, oops. X minus 2 squared. And what was it? Plus minus 2. X minus 2 squared minus 2. So he did say 2 units right. He said it's going to move 2 units right and 2 units down. And
Prove
he
this
looks like
statement.
he is correct. Okay, this thing is shifted right 2 units and down 2 units. Okay, it's been moved right 2 and down 2. So that's correct. The new vertex is 2 comma negative 2. So I'm just going to sketch this in my notebook. And again, he's correct. It shifted over right 2 and it shifted down 2 at the same time. So this is perfect. And we're going to look, of course, at why he's correct in 1 second. Okay, so 2 units right and 2 units down is correct. My new function is here. Not drawn to scale. Obviously, I'm doing the best I can here with a mouse. Okay, so there's the new parabola. It's moved 2 units right, 2 units down. And the question is why? So if you look at this, okay, um, I like identifying K first. K is the one that's right out here. So K in the K position is negative 2. So K equals negative 2. And that's why we got the down 2 units. And the H position, we need the negative. There is a negative. So H is 2 in this question. H is 2. And that's where the right 2 comes from. This is perfect. By the way, when you're finding H, you can just change the sign to find H because of the negation here. Just change the sign. So this becomes positive 2. Simple as that. So there we go. Perfect. Really quick because the time's right about to run out. I just want to finish this really fast. Anybody want to give me what happened in example 3? So what happened here?
I'll go.
Yeah, sure. Go ahead, man.
I don't know if it's right, but
It's
five
okay.
units left and 1 unit up.
5 left, and you are correct. 5 left, 1 up. Let's take a look at why that's the case. 5 left and 1 up. Okay, 5 left and 1 up. All right, I'm not going to have time to graph, and I apologize. If you do it on your own, you'll see that you have 5 units left is going to be here and 1 unit up. It's going to end up over here. He is going to be correct. Okay, he's going to be correct. And the reason that that is that it shifted over 5 units this way and 1 this way, okay, is because I like doing K first.
Negative.
K is 1. Yes, thank you. Thank you. H is negative 5 and K is equal to 1. All right, that's correct. You change the sign for H because you need a negative. So this becomes negative 5 and K stays the way it is. It's 1. So those are the values. His answer is correct. We get everything we need. So this is negative 5 and 1. So perfect. That's it. I don't have anything to add. Anybody have any questions before we go? I'm sorry, I'm over your time. My apologies. It took me a minute to set up, so I was a little slow today. Let me just read the chat really quick. What's this? All right. So that's all I have for today. Let me stop the recording. The exams, unfortunately, will count towards NP2. They needed the grades from me yesterday.